Hi there, Speak with Sarah here. Welcome to today's TOEFL listening practice. As always, this is a real academic style lecture designed to help you build comprehension, note-taking skills, and academic vocabulary. Let's dive in. Part 1. Opening and Introduction. Today's topic is one that sparks both scientific curiosity and imaginative storytelling, the physics of time travel. We'll examine what physics says about moving through time, why traveling to the future is theoretically possible, why traveling to the past is highly debated, and how fiction has explored these ideas for centuries. Time travel may sound like something straight out of a Hollywood blockbuster or a science fiction novel, but physics tells us it's not entirely impossible, at least in one direction. And, as we'll see, that direction is forward. Part 2. Time and Einstein's theory of relativity. To understand time travel, we need to start with Albert Einstein's theory of relativity, published in the early 20th century. Before Einstein, time was thought to be absolute, ticking away at the same rate for everyone, everywhere in the universe. Einstein showed, however, that this is not the case. In fact, time is relative, meaning it can stretch or compress depending on two factors: speed and gravity. Let's start with speed. According to special relativity, the closer you travel to the speed of light, the slower time passes for you compared to someone at rest. This is known as time dilation. An often cited example is the twin paradox. Imagine two identical twins. One stays on Earth while the other travels on a spaceship at near light speed. When the traveling twin returns, they will be younger than the twin who stayed behind. This isn't magic, it's a natural consequence of relativity, confirmed by precise atomic clock experiments. Gravity also affects time. Einstein's general relativity predicts that time runs more slowly in stronger gravitational fields. This effect has been measured near massive objects like planets. Astronauts aboard the International Space Station, though not very far from Earth, actually experience time at a slightly different rate than people on the ground, aging a fraction of a second less over many months. Part 3. Traveling to the future. Physics says yes. Given these principles, traveling into the future is not only theoretically possible, it's already happening, albeit in tiny amounts. Anytime you move quickly or spend time near a massive object, you are shifting relative to another person's clock. Now, to make significant jumps into the future, say decades or centuries, you'd need speeds close to light or gravitational forces near a black hole. This is far beyond our current technology, but it's not forbidden by the laws of physics. Part 4. Traveling to the past. Physics says maybe. The real controversy begins when we talk about traveling backwards in time. Some solutions to Einstein's equations suggest that past travel could be possible under exotic conditions. For example, wormholes. A wormhole is a hypothetical tunnel in space-time, potentially connecting two distant points in space, or even two different points in time. However, wormholes, if they exist at all, would require enormous amounts of negative energy to remain open, something we currently cannot produce. Even if a wormhole allowed past travel, it raises logical problems known as paradoxes. The most famous is the grandfather paradox. What happens if you travel backward in time and prevent your grandparents from meeting? If they never meet, you're never born, so how could you have traveled back in time in the first place? Some scientists suggest that paradoxes might be resolved by the idea of self-consistent timelines, where events adjust themselves so that the past cannot be changed, or by the concept of parallel universes, where changing the past simply creates a new branch of history. Part 5. Time travel in fiction literature. Time travel has fascinated writers long before Einstein's theories emerged. In literature, it serves as both a plot device and a way to explore human choices, morality, and destiny. One of the earliest examples is H.G. Wells's The Time Machine, written in 1895. A Victorian scientist invents a device to travel to the distant future. This novel popularized the idea of a mechanical time machine and explored the long-term fate of humanity. In Mark Twain's A Connecticut Yankee in King Arthur's Court, written 1889, the main character travels to medieval England, blending humor, satire, and commentary on technology. In more recent literature, Audrey Niffenegger's The Time Traveler's Wife tells a romantic yet tragic story about a man who involuntarily travels through time due to a genetic condition. And of course, Michael Crichton's Timeline, written 1999, uses quantum physics as a device for sending characters into 14th century France. While these works are fictional, they often engage with real scientific concepts, sometimes accurately, sometimes loosely, giving readers a creative way to think about complex theories. Part 6. Testing the theories. How do scientists test ideas about time travel? In reality, we can't send people centuries into the past or the future, but we can test the building blocks of these theories, like time dilation, using high-precision experiments. For example, in 1971, scientists placed synchronized atomic clocks on commercial airplanes flying around the world. When the planes returned, the airborne clocks showed slightly less time had passed than the ones on the ground, exactly as relativity predicted. Modern particle accelerators also show time dilation. Unstable particles moving at near light speeds survive longer than identical particles at rest. While these aren't time machines, in the science fiction sense, they are proof that time can behave in surprising ways under extreme conditions. Part 7. Conclusion and reflection. So is time travel real? To the future, yes, in principle, and in tiny amounts every day. To the past, maybe, but the challenges are enormous, and paradoxes might make it even more complicated or impossible. In the end, time travel remains a mix of firm physics and creative speculation. It inspires scientific research into the nature of space-time while also fueling countless works of fiction that ask what we would change or protect if we could move through time. Thank you for joining me today for TOEFL's listening practice. Consistent exposure to academic English is key to mastering comprehension and confidence. If you enjoyed this, like, comment, and subscribe for more Speak with Sarah.